Welcome to MathLink, where we're connecting the dots. I am Mr. C, and I'll be covering this particular lesson. And what we're going to talk about is a sphere and how to find the surface area and also the volume of a sphere. So let's get started. So let's talk about the sphere. And this is the shape of it. You can see there's circles inside of it that make it. So we're going to use some formulas that are similar to circles as far as area, maybe some level of looking at some other type. So let's talk about the sphere. It is a solid figure bound by curves and the surface of the area such that every point of the surface is the same distance called the middle. So you have the middle, you go north, south, east, west, northeast, and you just make that, and it makes you a three-dimensional. Since it's three-dimensional, you're going to be talking about units of cube units. So it's almost like that volume that we're looking at. So for example, a round ball, a basketball, golf balls, those are all spheres. And those are an example. And here's an example of how it looks. Now, the radius of a sphere is the length of any segment. Remember, we talked about that in the past videos, from the center to any point on the surface. So it's a segment from the center to any point of the surface. The diameter is a segment through the center with its endpoints on the curved surface. The diameter of the sphere is twice the radius. So let's look at this picture and look at some of the things I'm going to describe about this picture. If a plane cuts through the intersecting of a sphere, it does not go through the center. If it doesn't go through the center, it's called a small circle. And this here is a small circle, this part here. That's the small circle. Now, if a plane cuts through or intersects through the center of the sphere, then the large great circle, and it's the greatest circle. There's no other circle that's greater if it cuts through the center. So we have circles. So notice a sphere is really circles going up and down from different hemispheres. And so the great circle cuts the sphere in two equal parts called hemisphere. So we have hemisphere, and notice also this is the diameter from here to here, and the radius will be half of that from the center, and this is the radius. Okay, so that's a visual of a sphere. Now, these are two formulas you want to write down. To find the surface area of a sphere, is 4 times pi times r squared, where r is the radius. Again, pi is 3.14, but also you can look on your calculator and just use the pi function to use within the formula. 4 times pi times r squared. That's how you find the surface area. To find the volume of a sphere, it is 4/3 times pi times r cubed. Notice the difference where r is the radius again, if it's giving us the radius. So let's actually look how to do some problems that we have here. So this is an example. So we have a spherical gas storage tank, okay, and which has a 9.4-foot diameter and is to be painted. So we want to paint this sphere, and the diameter is 96.4 feet, okay? So we want to compute the surface area first of the tank. Now the surface area is the outer part, just the outer. We're not talking about what it holds, but the area of the surface area. And then we want to compute the nearest gallons amount of paint required. And notice this, we got to be given this. 1 gallon of paint covers 530 square feet. So 1 gallon covers 530 square feet. So first, let's figure out the area, the surface area. It's a good word, surface area of this sphere. Let's jump here. And to find the surface area, and I'm going to see if I can draw and delete my drawing. So here we have our three-dimensional sphere. And what we want to do is just find that surface area. We know that the diameter, which is from here to here, is 96.4 feet. So let's figure out the surface area. We'll just use our formula. So to find the surface area, let's say SA, it will equal to 4 times pi. Pi is 3.14 times our radius. Now, our radius, we don't have it. We have the diameter. Notice they gave us the diameter, so we have to take half of that to find our radius, okay? And it'd be radius squared. So we need to take half of this, which would be what? 48.2 square. Now, once we do all this, so go ahead and do this on your calculator, pause it, do this on your calculator. I think we end up with an approximation of 29,194. Okay. Now, since we're talking about painting this, let's round this up to like 29,200. And this is, since the surface area it'll be square foot in our case. So what I did was estimate it, so we make sure we have more than enough paint. So that's our answer for the first piece. So since that's my answer for the first piece, I'm just going to underline it. That's my answer for the first piece. Now we want to compute to the nearest gallon the amount of paint required. Now we know 1 gallon of paint covers 530 square feet. So how many paint do we need to be able to do this? And so what we should do, we should use 29,200 square feet divided by 530 square feet. That's 1 gallon of paint, 1 gallon. Once you do that division, that will give us approximation around 55 gallons. So we need 55 gallons of that paint to be able to cover that sphere. And that would be the answer of the second part of our problem. And I will circle that. Now let's look at another example. So we have a stainless steel ball bearing, contains balls that each is 1.0 centimeter in diameter. So make sure you know we're talking about diameter or radius, okay? It says find the volume. So I underline that, so that's the first thing, let's find that. And then find the weight of a ball to the nearest gram. Stainless steel weight, 7.88 grams per centimeter, cubic centimeter. So it gave us how much each of them weigh per cubic centimeter. So let's first find the value, and then let's do the second part of the problem. Now, also a sphere, we're going to look at it like this. We know that the volume is equal to 4/3 times pi times r cubed. So let's actually set this up. So this would be 4/3 times 3.14. Now again, I want to say this. If you're using the pi function on your calculator, you may be a little bit more precise and your answer may be a little bit different when we do it, because a more precise number for pi. I'm just stopping at second at 2 digits. So 3.14 times our radius. Now in this case, they did not give us the radius. They gave us the diameter. So we need to take half of that, 1.8, which would be 0.9. And then we'll just do the math here. Let's do this on our calculator. This should be about 3.05. Again, since it's volume, centimeter or cubic centimeter. So I'm going to write that. I'm just going to underline that. That's our first answer. Now, the second part says, find the weight of a ball, just one of the balls, to the nearest grams, where the stainless steel weighs 7.8 grams per cubic centimeters. So what do you think we need to do in order to find the weight of just one of the balls? That's correct. We're going to need to multiply that number that's underlined in green times 7.88, since that's how much per grams per centimeter cube. And since everything's in the same units, centimeter cubes, this is going to give me 2.4 once I do the math, and the final answer will be just in grams. I'll write down 2.4 grams. That will be the weight of the stainless ball. Now, hopefully this helped to show how to find the surface area and the volume of a sphere. Now, in this case, guys, you want to review the video again and basically those two formulas and know how to work those two formulas. And if you still have questions, look at some of the resources that we have on our MathLink website. Again, MathLink is about bringing it together. And again, thank you for watching this video.